Investment decision making using Excel. This video is the fourth in a series that discusses the essentials of effective investment decision making. Prior videos examined the net present value, maximum capital at risk, benefit cost ratio, internal rate of return, and payback. This video explains how to use these financial indicators to make investment decisions. Investments fall into two categories: mutually exclusive projects and independent projects. When deciding among mutually exclusive alternatives, investors must select the best project because they can only do one. On the other hand, investors can perform any number of independent projects, also called non-mutually exclusive projects, as long as they have enough money. With mutually exclusive investments, where an investor can only do one project, examples include: at what rate should a manufacturing company operate a particular plant? What size and type of pump best provides a specific service required? The best decision tool is the net present value. Select the highest net present value at a specific discount rate. With independent projects, where an investor can perform any number of projects within funding limits, examples include: how should management allocate money among various divisions of a large company? How should a firm prioritize investments for different endeavors? The best decision tool is the benefit cost ratio. Rank projects according to their benefit cost ratio at a specific discount rate. The highest ratio is the best project. This table summarizes what we've just covered. You can use internal rate of return to select the best option for mutually exclusive alternatives, but to do so you must find the IRR for each increment of capital invested. On the other hand, internal rate of return fails to consistently rank independent projects. Maximum capital at risk and counting rate of return, which we've not discussed in these videos, they present useful information, but they fail both at ranking independent projects and selecting the best project from a group of mutually exclusive projects. Earlier we considered the discount rate, which is the interest rate used to evaluate projects. As an investor or analyst, you must determine your minimum acceptable rate of return. You'll recall that the minimum acceptable rate of return is also called the hurdle rate or discount rate. You have to use the same discount rate on all projects to make consistent decisions. Factors influencing decision making are capital and operating costs. Accurate projections require historical knowledge and thorough analysis. Finally, nothing impacts a project cash flow more than revenue. You have to do your homework to make well-considered estimates of future revenues. You can find the Microsoft Excel workbook that accompanies this video at toweringskills.com/docs/FA002.XLSX. Select tab 4. Example 4 shows two mutually exclusive projects, and it also shows the incremental analysis. The discount rate shown here in cell B4, 10%. Alternative 1 generates a net present value of $33,000 as shown in cell 15. While Alternative 2 generates a net present value of $39,000 shown in cell C28. Clearly, Alternative 2 is better at the specified discount rate of 10% because the NPV for Alternative 2 exceeds the NPV for Alternative 1. We also can see in the incremental analysis at the bottom of the page at cells C39 and C41. Now consider example 5 on sheet 5, where management increases the discount rate to 15% as shown in cell B4. Alternative 1 generates an NPV of $17,000 as shown in cell C15, while Alternative 2 generates an NPV of $11,000 as shown in cell C28. Alternative 1 is now better at the specified discount rate of 15%. If you were to do Alternative 2, you would still achieve an overall internal rate of return of 17.3%. But the incremental IRR on the last $100,000 spent falls to 12.4% as shown in cell C41. This, of course, is less than the hurdle rate of 15%. Now let's look at independent, non-mutually exclusive projects. We'll return to sheet 2. This example shows 4 independent projects. Project 1 has the largest net present value and therefore is the best project. You'll see this in cell C15 with the BCR being 1.8. The other projects are 1.18, 1.14, and 0.88. Example 6 on tab 6 shows another set of independent projects. Project 2 is best here because at the given discount rate of 15%, the benefit cost ratio for Project 2 is the highest, it being 1.73, as seen in cells C27 and also in the summary at the bottom in cell E57. If we increase the discount rate to 25%, we see that Project 1 now becomes the superior project with a benefit cost ratio of 1.18. This underscores the importance of being clear on the hurdle rate. To recap, if you calculate the net present value, benefit cost ratio, internal rate of return, maximum capital at risk, and payback, you'll have all the financial measures required both to compare your project to other projects and to sell your project to sponsors and to stakeholders. The net present value provides the means to select the best mutually exclusive alternative, while the benefit cost ratio presents a gauge to rank your project against other independent projects. The internal rate of return, maximum capital at risk, and payback provide other valuable information to help measure a project's potential and to measure its performance. To see the prior videos in this series, click here. To learn more, go to toweringskills.com.